So, hello guys, welcome to a new video. Today we are going to discuss the topic exception handling in Python. I'm Hanikushan. So, let's start the video. So, what is need for exception handling? Exceptions are errors detecting during execution. They can disrupt normal program flow and lead to crashes if not handled. Exception handling lets you manage such errors gracefully. Basically, when we execute code and when the code is syntactically incorrect, then the errors may raise. To avoid these errors, we use exception handling. Let's try to execute a code and see the output. So let's run this code and see the output. The system is asking to enter a number. I'll enter 2. No error occurred, so output is nothing. We'll run again. I'll enter 0. C. 10 by 0 can't be divided. So the error not raised, but it gave an, what we say? It gave an message to the user. Let's give another output. I'll give some letter alphabet. I give L. See, enter a valid integer. Let's run this code and see the output. See, it's asking to enter a number. I'll give 5. Nothing. It did nothing. Now I'll give 0. See, it raised an error and execution stopped. So to avoid this execution stopping, we use try except blocks. We can also use else statement in these blocks. When there is no error or no error raised, directly else statement execute. See, I've entered 4, no error raised, uh, except zero division error statement skipped, value error skipped. Directly the control jump to else statement and printed this statement. Next comes the finally block. The finally block is always executed regardless of exception occurrence. We will see the example for this. See, I have typed the final block here. Regardless of raising error, the finally block will be executed when we run the code. Let's see an example. I am giving 0 to raise an error intentionally. I gave 0. See, an error raised, 0 can't be divided. Then value error skipped because 0 division error has raised. These two statements skipped. Finally, the finally block statement executed. Execution completed. So we can create our custom exception. To create our custom exception as our requirement, we use a rise keyword. Let's see an example for this. So this is the example code for custom error. So generally I have created a class for my required custom error and inherited the exception characteristics. I used raise keyword for calling my error class I have created. Let's run this and see the output. See. So that's it for this video. We'll meet in next video. Until then, see you.